Okay, let's go ahead. Let me go ahead and set up the problems from section 11.4 for you. I'll let you do the calculator work, but just want to do a video on section 11.4. All right, so the big idea in section 11.4 is learning how to use this formula for figuring out the probability of exactly X successes in N trials, okay, where P is the probability of a success happening and Q is the probability of a failure happening. Okay, so you know about this formula. Let's just work on a couple of problems, getting them all set up. Problems 1 through 6 on the worksheet. Okay, so on the first one, we literally are just plugging in and making sure that we're using the calculator correctly. So we want the probability of 5 successes because X, they told us X was 5. N is 17. So we're going to do 17, choose 5. All right, the probability P, they told us, was 1/7. Okay, we want that to happen 5 times because 1/7 is the probability of a success. We have 5 successes. Okay, if 1/7 is the probability of something happening, then 6/7 would be the probability of it not happening. So we've talked about how these two should add up to be one whole. So we got 6/7 by taking 1/7 away from 1. And then the number of times that we're going to have a failure would be 17 minus 5, which would be 12. So 12 came from me taking 17 minus 5. The 5 and the 12 should add up to be n. So whatever I put here has to add up to be n. So 1/7 plus 6/7 should be 1, and 5 and 12 should add up to be 17, should add up to be your n. So type that in and do the work, and you can check the answer key. It's on there too. But once you type it in, you should get 0.0579 if you rounded to 4 decimal places. All right, same deal on question number 2. The probability of exactly 9 successes out of 11, because n is 11, so 11 goes in front. Choose 9. Then you should do 0.7 raised to the 9th power. And then let me erase this from the previous spot. And then it should be 0.3, because 0.7 taken away from 1 would give me 0.3. 0.3 needs to be raised to the 2nd power, because to get this, I take n and I subtract x from it, or I think 9 plus 2 would give me 11. Then I work that out and I'll get 0.1998 if I round to 4 decimal places. All right, on number 3, this one was in context a little more than the others. They didn't spell everything out for you like they did before. So on this one, the n would be the number of times you're rolling the die. That's 11. We want to get 3 6s. We're going to think about getting a 6 as being a success, and we want 3 6s. So x would be 3. Okay. The probability of getting a 6 would be P. That's 1 out of 6. And the probability of not getting a 6 then would be 5 out of 6. So on this one, when you set it up, you're going to set it up the probability of exactly 3 6s. It would be 11, choose 3, then 1/6 to the 3rd power, and then 5/6 to the rest, the 8th power. And then you would work that out. And the answer should be 0.177, I think it was 1777 if you rounded to 4 decimal places. All right, on 4, this one was also in context. We had a company manufacturing calculators. They came in batches of 64, and there's a 4% rate of defects. 4% is the same as 0.04 as a decimal. Find the probability of getting exactly 3 defects, exactly 3. So that means I can use the formula, right? N on this one would be the 64 that are in a batch. Okay, the X would be how many that we expect to have defects, or that we want to have defects, and it was the probability of getting exactly 3. So we'd say 3 defects would be X. And then P is the probability of getting a defect. That's 0.04. So Q would equal 1 minus that. 1 minus 0.04 would equal 0.96. Okay. Then you just put it all together in the formula. Okay. We wanted exactly 3 defects. So we want the probability of exactly 3 successes, considering a defect a success, would be 64, choose 3. And then it would be 0.04 raised to the third power, and then 0.96 raised to the rest, which would be the 8th power. Right? Oops, no, I was thinking about the previous question. I forgot. I was thinking about the previous question because it was also exactly 3, but we had 64 calculators on this one. So it'd be raised to the 61st power. I'd get that by subtracting 3 from 64. Okay, and then type that in. And let's see, if I rounded to 4 decimal places, it was 0.2210. And I'm not sure what they wanted that rounded to. All right, number 5. Here we're dealing with a family. 5 children in the family. That's your N on all of them. Okay, probability of having a girl. That's going to be our P. The probability of not having a girl. That's going to be our Q. And then X depends on which of the questions we're doing. Having no girls would be X being 0. Exactly 1 girl, X would equal 1. Exactly 2 girls, X would equal 2. Okay. When we get to no more than 2 and at least 4, those are going to involve multiple uses of the formula. Okay. So I'm not going to take time to put the answers. They're on the answer sheet. Let's go ahead and just set all of these up. So wouldn't this one, the probability of no girls, equal 5, choose 0, and then 1/2 to the 0 power, and then 1/2 raised to the 5th power. The first 1/2 is the probability of having a girl. You don't want any. And then the second 1/2 is the probability of not having a girl, which would be having a boy, and that should be then to the 5th power. Okay, then do something similar on the rest. The probability of exactly 1 girl would be 5, choose 1. Would be 1/2 to the first, and then 1/2 to the 4th. Exactly 2 girls would be the probability of exactly 2. 5, choose 2. And then 1/2 raised to the 2nd power, and then 1/2 raised to the 3rd power. All right. What's going to happen on the next ones is you'll have to use the formula more than one time. No more than 2 girls means X could equal no girls, 1 girl, or 2. It just can't be more than that. So it can't be 3 or 4. So to do that one, you're going to take what you got for the probability of no girls and just add the probability of exactly 1 and the probability of exactly 2, and that's going to be your answer. So you'd have to, if you hadn't already done it, you'd have to use the formula 3 times and then add those values together. Right? And then at least 4 means you could have 4 or 5 girls. So that means you'll have to do the probability of exactly 4 plus the probability of exactly 5 girls. And that we hadn't set up earlier, but we've been setting those up. So you would set up it very similarly to what we did on the earlier ones on question 5. All right, let's look at question number 6. All right, this one said find the probability that when a 10-question multiple choice test has 4 possible answers for each question, a student will get at least 8 questions correct. Okay. That question's missing a little something. It should have said, find the probability that when a 10-question multiple choice test has 4 possible answers for each question, a student will get at least 8 questions correct And it's really if they guessed, assuming they just guessed on every one. So we're kind of, that's usually in this kind of question, assuming they guessed on every one. Okay. All right. That's not a big deal. I'll probably have that though if I use this question again. All right. So 4 possible answers means that you have a 1 out of 4 chance of getting the question right. That's P. And you have a 3 out of 4 chance of getting it wrong. If there had been 5 answers, it would have been a 1 out of 5 chance of being correct, and then 4 out of 5 of being wrong. Okay. 10 question test. 10 question test means that n equals 10. And then it says at least 8 questions correct. So that means getting 8, 9, or 10 correct. Okay. So you're going to have to use the formula multiple times. So you're going to have to do P of 8, then you're going to have to do P of 9, and then P of 10. And then when you're finished, you're going to add those together. Okay. And I'll set up P of 8. So that would be 10 questions. Choose 8. You want 8 of them right, which means 2 of them wrong. Okay. And then you would do the same thing for 9 and 10. 10 choose 9, 9 of them right, 1 of them wrong. And then 10 choose 10, all of them right, and then none of them wrong. So those are going to be pretty small. They're going to have a lot of zeros after the decimal. So don't round too much when you do those individual ones, and then just work it out and see what you get on that. Okay. I think I rounded on the answers. I didn't bring it, but I think I kept a little more accuracy when I was rounding, like 5 decimal places at the end. You should round these in here. Don't round them very much. Keep a lot of accuracy there. Okay. So the problems that you'll see on 11.4 are just going to be using this formula right here and making sure you can do it when it's real straightforward, and then making sure you know how to identify the N, the X, the P, right? And that you understand how to get the exponents on those. Figure out the Q and get the exponents on those. Okay.